Hello everyone, my name is Andres Martinez, and today I'm going to teach you about finding the basis of the column space of A and the null space of A, where A is this matrix. So just a little theory behind the column space of A is that column space of A is basically the range of A's linear transformation. So here's what the linear transformation of A would look like, where A is any n by n matrix. And I'm really only doing this just to try to illustrate this point to you. Here we have the linear transformation basically drawn out to see how it works. So here, this is a domain. The domain is r to the n, and any x value, any x vector that's in r to the n gets inputted into the linear transformation, and then it maps out here A times x to the x vector, which is essentially the linear transformation, and that's going to be in the space r to the m. So this is a domain and this is a codomain. However, since it's a codomain, it's not necessarily the range unless it's onto. If you have no clue what onto is, then probably look it up, because this part of linear algebra you kind of need to know. So here, again, this is a codomain, which means that for the column space of A to be the range, it has to be a subset of r to the m. So it's basically a subspace inside the space r to the m. Alright, so now I'm going to teach you how to solve this problem, which is basically we take this matrix right here and we're going to row reduce it. So here I have all the steps that I showed to row reduce it. Here in the first step was I left the first row the same. I added R1 to the second row, and for R3, or the third row, I said R3 minus 2 times R1, and then for the last row I said, let it clear up for a second. Okay, and for the last row I said R4 minus R1. And then I ended up having this. However, this is not row reduced yet, as there are no pivot columns, as there's no pivot columns in the diagonals, or just in every row, or how many pivot columns that you can have. And here, the second step, I said R1 is the same again, R2 is the same again, and then R3 is actually the same again. It's just R4 that I switched and I minus R2 twice there, and here I'm pretty sure, let it clear up for a second, whatever, that is minus 3 R3. Okay, so now that we have that, we have this row reduced form of the original matrix. So now that we have the row reduced form, we can find the pivot columns. The pivot columns are x1, x2, and x3. So now we look back at the original matrix, this one, and row 1, row 2, and row 3 are going to be the vectors that make the basis for column space of A. So then the answer is, the basis for column space of A is those 3 vectors. Okay, let it clear up so you can see that. There you go. Right, now the second part is, how do you find the null space of A? Well, the null space of A is basically a subspace for all x, where the linear transformation of A times x is 0. So basically, when this equation right here, the matrix A times the vector x equals the 0 vector, is true, and this is true. I'm sorry. All x values where this is true, that's the null space. Okay, so here, in order to solve this, we're going to have to solve the equation A times x equals the 0 vector, and this is basically the equation which can be rewritten as the augmented matrix of the A vector that we were given with the 0 vector. So I had already row reduced the matrix that was given, and it gave this. Okay, now that this is row reduced, we can continue to solve this equation in a form that will give us an infinite amount of solutions for every single x where A times the x vector equals the 0 vector. So here, again, this is just rewriting it. This is what we have after we row reduced the matrix. And now I'm going to write the corresponding equations to this matrix, which is x1 minus x2 plus x3 minus 2x4 equals 0. And then here, just so you can see how I'm getting this from, 0 plus 2x2 plus 0 minus 2x4 equals 0, and 0. And then for the third row, it's 0 plus 0 minus 4x3 plus 7 times x4. What you want to do is write the pivot column variables, which are x1, x2, and x3, in terms of the only free variable that we have, which is x4. So it's a free variable because it doesn't have any pivots in its column. So now that I did that here, we see that x1 equals 5 over 4 x4, x3 equals x4, no, not x3, x2 equals x4, and x3 equals 7 over 4 times x4. Right? So now that we have that, we can rewrite x, the x vector, which is essentially just x1. Here are all of its components just based on what the matrix is. And we can rewrite those as 5 over 4 x4, x4, 7 over 4 x4, x4, and we rewrite that as x4 times the vector 5 over 4, 1, 7 over 4, 1. And then the basis, therefore the basis for the null space of A is going to be that vector, which is 5 over 4, 1, 7 over 4, 1. Thank you very much. My name is Martinez.